Welcome to Map to the Stars, where we're going to talk about variable arguments in Python functions. So normally, when you define a function, you have a fixed number of positional arguments. In this case, we've defined a function f11 with 0 arguments. Doesn't do very much. And when we call it, what happens with no arguments? It executes. Nothing, doesn't say anything because there's nothing to say. It's very simple. But what happens when we call it with 1 argument? Well, we get an error. Function 1 takes 0 positional arguments, but 1 was given. So this gives rise to an observation of one of the few times where Python actually does some basic type checking. Whenever you define a function and call that function, it checks to make sure that the number of arguments is correct. It doesn't check anything beyond that, like what the types are, but it will check the numbers of the arguments. So like here's another case where we define function 2 to have 2 arguments, a and b, and we'll print out what those values are. So let's call it with just 1 argument. What will happen? Well, we know what will happen. We will get an error because it's missing 1. So it's making sure, we define it with 2, making sure 2 arguments are there. When we call it with 2, wow, it actually runs and prints out, as we told it to, the values of those arguments. Now, if we add a 3rd argument to it, we can guess what will happen. We'll get a type error because we defined it with 2, but we just gave it a 3rd, and it gets upset. So that's basic positional arguments, which is the most basic of all functions, and anyone who does anything in Python knows how positional arguments work. The order is what's important. The number of arguments have to be compatible that you use, that when you call it, have to be compatible with how it was defined. But in addition to that, most people are familiar with what are called keyword arguments, where here's a positional argument. It's not required, but there is one here in this function. We define a keyword where you define the variable name followed by a value. Variable name followed by a value. Any number of these can be there. And they're optional. In other words, you don't have to call the function with these keywords, but if you don't include them, these values that you give here in the definition are default values, and we'll set the value of this identifier to be that value. And these values can be any Python object. I have this one's a string, this one is none. So keywords are very useful when you want to have, well, they're useful for a number of reasons. One is the naming can be can really be helpful for documentation purposes. I mean, for nothing else, because when you just have a bunch of positional arguments, you don't really know what they are. Keywords, you can be, sort of define what they are, and it's good so that people can see what you're doing. And then, of course, the other is because they're optional. You don't have to have them, and if they're not there, they take on these default values. So let's see. We define function 3, and if we call function 3 with no arguments at all, what will happen? Well, we kind of know. The positional argument in this particular function is required, and so we will get an error, missing required positional argument A. So if we call it with 1 argument, that should be okay. Because like I said, these keyword arguments are optional. And we're printing out what they are, and notice A was what we passed in right here, but the keyword arguments are there. These identifiers, key 1, key x, with exactly what the defaults were. So in our function, we can use those and do whatever we want with them. If we take like key 1, for example, and define it to be something else, what do we get? It will be the value that we set it to. So this is these can be very useful. Notice that key X is still the default. We can take key X, define it instead. Key X is dog, and key 1, which was dog before, as a default, so they're both dog now. Key X and key 1. The order in which they're set doesn't matter. So here we just reverse the order, set them to be whatever, and boom, there we go. It worked. Okay? Now, important thing is that when you have these fixed number of keyword arguments, is what we're showing here, where we've defined two keywords, key 1 and key X, it means that you must use either, you don't have to have them, but if you have them, they have to be one or the other. You can't define your own key here. So if I define new key equal line, it'll get upset and say, wow, just got an unexpected keyword. Okay? So that's basic functions 101, fixed positional arguments and optional keyword arguments. But there can be a lot more to that, to Python and their arguments. One is variable positional arguments. So this allows you to add any number of positional arguments that are optional. Any number. You don't have to have defined your function with those numbers like we said before. Like we showed you before that, if you had 0 functions and if you had 0 arguments and you call it with 1 argument, it all got upset. No. So what would happen if we wanted to write a function that took a variable number of positional arguments? In other words, maybe 1 or 2 were required, or maybe not, but there could be like maybe 5 or 10 or 3 or any number of other positional arguments that we would like the function to handle without it erroring off like it did before. Well, that's very easy. What we do is use a star and asterisk. So the default name of this variable is called args. That's typically what people, not default name, but conventional name. It can be anything though. But if you define a function with star argument, that means that it is basically passed in as an array to the interior of the function, and that inside the array can be any number of values that you can then go through in a for loop, let's say, or by indexing it explicitly, or any which way. You can go through this array and grab all these arguments. So what we're doing here in function 4, is we are just printing out the type, just so you can see the length, since it is a list and it will have a length. And then in a little loop here, this for loop, we're going through and printing out each value, okay? Arg equal arg. So let's see what happens. If we define function 4 to be star args, let's call it with no arguments. Now it looks like it requires an argument, but since that's a star, not really. It's really a implicit array, and inside the function it can have 0 length and it's okay. So when we do this and call it with no arguments, we don't get an error. It's an array. Well, it's actually not an array, it's a tuple, but the same idea. A tuple is just like an array, except it's immutable. But I've been saying array. Tuple is more accurate, of length 0 in this particular case, because we don't have any arguments. But what happens if we pass it, say, with 3 arguments? What do we get? Wow, look at this. So 1, 2, and 3, we get the tuple. It has a length 3. We go through our little for loop, and 1, 2, and 3, and prints them out. So you call it like this. You define it like this. And you could have 20 or 100 or 1,000 arguments. Now, that doesn't mean your function will be happy with all of that, and inside the function you can look. You can see, is this length too long? Is it too short? Is it right? whatever it is you're expecting and what it is you want to do, but you don't have to write the function so that they're all defined. This is all you have to do. And it's very handy for in certain circumstances. I don't recommend that you do this all the time, but there are times when you want to do this. Okay? Now here's an example of a function where you have required positional arguments, A and B, in addition to the optional positional arguments. Okay? So you can have both. You could have any number of required, and then you could have any number of variable inside this star value. And you can only have one star value, if any. Remember, you don't need any, but if you want it, you only have one. And it has to be following the fixed positional ones. Okay? So here in this case, we're just going to print the value of A and B just to see what they are, and then we're going to loop through the array and just see what they are. Okay? Function 5, we'll call it with no arguments. Well, what do you think will happen? Whoa, 2 positional arguments are missing. It's just like before, where we've defined it with fixed positional arguments, because we've defined A and B here, so it requires that they're there. If it has 1 argument, again, it'll say 1's missing, B is missing. But if we have 2, everything's fine because we defined it as 2 plus this optional list of arguments. And this is really, here we have 1, 2, 3, 4, 5. So what will happen is 1 and 2 are the positional ones that are required, 1 and 2. Then 3, 4, and 5 are the ones that are passed in the array, and we loop through it, and so we have 3, 4, 5. So even though when you call it looks just like this, inside the function, really 1 and 2 have identifiers associated with them, whereas 3, 4, and 5 are just positions in the array. Okay? We can do similar things with keyword arguments. Here's a very simple example where we accept a variable number of keywords. And in order to do that, what you do is you use 2 asterisks, which really means that the keyword arguments are passed inside the function as a dictionary. They look on the outside as they normally would, but the function interprets it as a dictionary. And so you can have a variable number of them. So let's just look at this here. Now here we're printing out what the type of keyword args is, just so we could see what it really is. Then we're assuming it's a dictionary, and we're just looking at the key and value for each item there. Okay, and printing them out. Let's see what happens. So function 6, let's call it with no arguments. What do we get? Well, we do see that it is a dictionary, but it's empty. Now let's call it with 1 argument. If we call it with 1 argument, guess what? We get an error. Why? Because it's not a keyword argument. It looks like it's a positional argument. But the way we've defined this function, there are no positional arguments, only keyword arguments. So that's why we're getting this error. Now, if we call it like this, however, notice KWArgs, and this is the convention for variable number of keyword arguments, is KWRs, but the name can actually be anything. But in this case, we're defining my key equal dog, your key equal cat. They don't appear here in the definition at all. And remember, if we didn't have the star star here, and if we said this and it didn't appear, we'd get an error. But guess what? We don't now, because of that star star. And it's the dictionary, and then it loops through the dictionary, key and value for each item. And we get my key, and the value is dog. Your key, the value is cat. Once again, to keep in mind, there's 2 parts of these variable number of arguments. There's how you define the function and how you call the function. We've been calling the function like the keyword arguments with keywords. And we called the positional variable number of positional arguments with positional arguments. There's another way you can do it, and it's a shortcut. So like for instance, if we had an array defined in our program, say a simple list, dog, cat, and goat. And let's suppose we want to call function 4 with this array. Now function 4 is, let's find it here, takes a variable number of positional arguments. Positional. And let's suppose we want dog, cat, and goat to be positional arguments, but they're already in an array. So we say, oh, well, maybe we'll just pass it as the array and it doesn't have to turn it into an array. Let's just try and see what happens. Well, if you really think about it, you can see it doesn't work because basically function 4 takes this argument, A, in the tuple, it's length 1, but it's the entire array, the entire list is the argument itself. So it doesn't split it up into pieces. It thinks it's the array, so it has one argument, and that argument is this array. It's not exactly what we want, so there is this feature, a shortcut, where you can put star A when you're calling the function, not defining it. And it will automatically take these individual arguments and put them like you were calling them directly. So, for instance, if we call function 4 star A, we get arg, cat, and dog. So there are 3 positional, optional positional arguments, and it finds them. They're all inside this array. And it's exactly equivalent to as if we had called it like this. But you don't have to unpack the array. It does it automatically. That's what this shorthand star A does. It makes star A, using this array, totally equivalent to this. And similarly, and you can see we got the same result. Similarly, we have, if you suppose you're writing a program and you have a dictionary, and it's got key 1 is dog, key 2 is cat. And we want to call function 6 with this. Now function 6, if you recall, takes a variable number of keyword arguments. Okay? And let's suppose we'd like to just pass the whole, since this, we sort of thought, well, inside the function is a dictionary, maybe we can just pass the dictionary directly and be done with it. So let's try that. But no, it's not going to work because, again, it's sort of the same issue arises here in that it takes a variable number of keyword arguments, but it looks like this is just a single dictionary that it's passing in. It doesn't like that. Well, just like analogous to the positional arguments keyword, if you put 2 stars before the dictionary, it assumes they're all keyword arguments. So what you get is if you do that, it'll act like you called this function with keyword arguments. In other words, star star B, where B is this dictionary, when you call it, is totally equivalent to this, calling it where key 1 equal dog and key 2 equal cat. So it's a shorthand. Again, please remember that the star and the star star have different meanings, slightly different meanings for defining the function and when you call a function. And that can be a source of confusion. So here's an example of where we mix them all together. This is sort of a goulash, where we've defined function 7 to be arg1 and arg2, which are fixed positional, a variable number of positional arguments here, a fixed keyword argument in the sense that we're specifying this thing called other, this other keyword, to be dog. Okay? And then a variable number of keywords. So you can mix and match these things, and there's a lot of permutations. The order is very important. So you have to have the, like we said before, you have to have the fixed, the required ones first. The optional positional would be following. If you have a specific keyword, then it has to be here. And if you have a variable number of keywords, it has to follow at the end. Okay? So all we do here is we're going to print argument 1 and argument 2. Then we're going to take the optional positional list and go through the list and printing each argument inside the list. And then for each of the keyword args, we're going to go through that dictionary and print out the key and the value. Okay? And then we'll print out this other one here that's just by itself. Keyword argument that's not required, remember, but it is, you're putting it there explicitly. I don't know what they call them. Might be a word for that. So here's function 7. Now if we call it with no arguments, what will happen? We all know. It'll get all upset because there's 2 positional it's requiring. So if we call it with 2 positional, it's happy because those are required and everything else is optional. So we have 1 and 2, arg1 and arg2, and then other is dog because we always said, just like without the keyword arguments, other is a keyword, but it will always have the optional value of dog. Here's where we call it 1, 2, and 3, and 4. In this case, it's very similar to what we did before. arg1 and arg2. arg3 and 4 are optional positional. They come out, and then other equal dog is still there because nothing's changed there. Now, this one, we're changing other to be cat. Perfectly legitimate. Instead of dog, it's now cat. And in this case, we have our 1, 2, and then our, which are required. We have some positionals here. Then we're defining a new keyword that's never came up, but it's fine and it's legitimate because we have optional number of keywords here. And if we do life is good, we indeed get it in addition to other equal dog. Have fun.